let's go ahead and get started. Whoops. Okay. Yeah, I know how that works. Okay. All right. So, couple things. Because I'm on my yearly mission to try to see if I can't get Linux working on this laptop, and last attempt did not go well. So expect to see my a fresh install a couple times over the next couple weeks on different operating systems. Don't let that bother you. That's my problem, not yours. But it is one advantage to do something. A number of you. So this is the plan: installing Python and Pygame on my computer. Talking about the rest of the semester. Then we're going to go and have some fun with my selection of stuff. Okay. So first, for those of you who are working in Pygame, installing Pygame can be a bit of a issue, or mainly because you don't know how to do it your first time around. So, a worst case scenario, you have to download Python again. Right? Worst case scenario, you have to download again, specifically because there's one thing we want to be able to check the box on, which is add Python, this down here, add python.exe to path. Okay, the reason for this is that I want to be able to use it in the terminal, right? I'll go ahead and use admin privileges, and then, let's see. So it includes, notice over here it says includes idle, pip, and documentation. Adding it to the path just makes what I'm about to do easier. You don't need to reinstall it. It just makes what I'm about to do a lot easier. Okay? So, there we go. And mainly is that if you don't add it to the path when you try to do Python, like this, and this is on Windows, you'll get a prompt to install it from like the Windows Store or something like that. Okay? Or for those of you who are running Mac, this shouldn't be an issue, right? But you'll want to follow the directions, some of the, not the install directions, but other directions they'll have. What we're concerning ourselves with is pip. Okay, so this is for those students, that significant subset of students who want to use Pygame. Okay, and it will tell you, okay, how do you install it? It just gives you that command. Python 3-m, all that stuff. Getting started. Right? The main thing is to use it says the best way to install Pygame is to use the pip tool, which is what Python uses to install packages. In other words, new things to import. Okay, this comes in Python with recent versions. So, disable path length. Yeah, whatever, doesn't matter. Close. So, the easiest, most straightforward way to do that is I'm going to boot up terminal. Right, you can confirm that Python's installed. So here's my Python shell, right? I could do print hello over here. It prints out hello. So go ahead and settings, appearance, color schemes. No. Come on. Certainly there is a way to make it look bigger. Ow. Sorry, I've got a bit of a headache. Okay. Discard changes. Can I just simply do it like this? Yes, I can. Great. Good old control scroll, right? So anyway, you don't need to do any of that. I'm just kind of showing that I can confirm that it's working like this. And so now if I try using a command on my computer called pip, it works. Or rather, I get a bunch of text rather than saying, hey, I don't know what pip is, right? So here I get a bunch of text saying, hey, we've got something called pip. What do you want to do with it? And I just simply say pip install Pygame. And we can confirm, before I do that, I'm going to do a before and after. Import Pygame. Nope. And you could test it on idle as well. Now I could do pip install Pygame. and you'll get all of this cool stuff going on here, and it says, hey, we're installing it, right? And it works on it. It says, not a problem with pip. Okay. What'd you do? What's wrong? What did I do here? What happened here? Exited with error. Interesting. That's fascinating. Normally it's just simply, okay, well, maybe do I need to upgrade pip? Because literally when I went to do this last time, it went in front of the student, went no problem. Okay, pip install Pygame. Nope. Well, yeah, I have no idea why that didn't work.
I had the same issue. Downloading CE worked for me.
Downloading CE?
Yeah, Pygame CE.
Pip install Pygame CE?
Yeah, like dash CE.
What's Pygame dash CE?
The community.
Huh. Interesting. Why does it need that as opposed to just Pygame these days? What happened with that? Weird. Okay. I've never seen that before. I don't want to say download something I am unfamiliar with, which is Pygame-CE. What's going on here? Fork. All right, seems fine. Yeah, that's what I expected. Thank you for that. Wasn't aware that was going on. Import Pygame. Ta-da! And now I'll be able to use Pygame. Assuming it's actually working. Yep, there we go. And they're saying, hey, you've got Pygame working. Great. Okay. So, scheduling time. All right. So the next couple so let's look at what we've got for the next couple weeks, because it's a bit horrifying, to be honest. Right? We've got this week, we got next week, then we got fall break, thank God, right? Yeah. And then we got to resume our classes, and then we've got the last day of class the week after that. Right? So we've got 1 week after fall break. All right. So let's go ahead and figure out what the schedule is. So today is what I typically call my Florida Man lecture, where I'll be talking about regular expressions of all things. Today and on Thursday, I will be going over regular expressions. 18, I will be doing probably a review of some kind. I might, if there's time for Pig, I'll do it there, but I'll be doing some kind of review, some kind of exercises. If I need to go over more regular expressions, I will. On the 30th, another grad student is asked to do another AI-related experiment in class. And I think it's a good warm-up / warm-down for the rest of the semester, like basically just solving a problem. Although completely different focus here on what the AI does. And I'll be in class kind of exercises, practicing programming. And for that one, I I've got to give some reward. Possibly I might give a couple of points on the exam 2 grade. So that might, to just kind of boost it. Not too many, but enough to incentivize you not to like skip out of the last day of school, last couple of days before the break. During fall break, of course, I'm not going to be doing anything other than meeting with students who are in need of help. I'll be available over Zoom basically the entire break. I don't really plan on doing anything other than working on, than basically doing housework, keeping up with, hanging out with my kid, relaxing. If anybody knows any good vegetarian recipes, by the way, for like Thanksgiving, please send them my way. My wife and kid are vegetarian, which means I eat a lot of vegetarian food, which is nice because that means I get to keep kosher a lot of the time. And honestly, it's been a great time recently because there's just there's a lot of fake meat out there, that has been really good. It's been a lot easier to be a vegetarian in the past decade than it has the decade before for anybody trying to do that. It's just more of a chance thing for me. You'll see me eating plenty of meat if you see me for lunch, but at home I eat a lot of plant stuff. It's a wonderful thing to be able to try so many foods, and I recommend it heartily to just try any food from any culture, any kind of diet, just because it's great to being able to experience so many things. All right, but anyway, during that break, feel free to reach out to me. Don't feel bad about poking me, please. Okay? And then we've got the week back. So I do have to place a third exam somewhere. And I think the easiest thing to do for everybody involved is to put it the last day of physical lecture. That means December 4th. Last day of class. Rather than holding it in your last lab, we'll do it in the last day of lecture on December 4th, which cleanly means that, and this actually, if we work backwards from that, then everything becomes pretty darn clean, because that means I need to do a review for that lecture. So the day to do it is always the lecture before the exam, which means we'll do our lecture on the 2nd, which means releasing the practice exam next week so that you can have plenty of time to review on that. Now, what is going to be new on the practice exam? The answer is not much. The answer is, for exam 3, what we're going to be talking about primarily is regular expressions, which we go in today. Now, here's the fun part about regular expressions. They take about 2 hours of really dedicated solo time to get a good grasp on, or enough of a grasp you need for the exam. 2 hours. But those 2 hours will pay you dividends far beyond anything than you would get in this class. You see, regular expressions have this awful thing that they don't fit cleanly into a computer science curriculum. They don't. I learned about them in a 4,000 level class on computational theory, which basically said we are going to set out to mathematically prove from the ground up what a computer can or can't do with, basically going all the way to the Church-Turing thesis, essentially. Just saying, basically, here is what we can do mathematically as computers. This is why Turing is called the father of computation, because he mathematically proved this is what you can do with what I'm going to call a Turing machine. No ego there whatsoever. So today and on Thursday, we'll be going over regular expressions, probably on next Tuesday as well, with a special focus on what you need to know for the exam and for the final exam. Okay? Now, to clarify, we have 3 exams and a final. Okay? We drop the lowest exam grade. Okay. Now, let's start again. Let's keep going. Let's start with this. Let's keep going with this whole, let's work from the back and keep going. Okay? Work from the back and keep going. Come on, Geenie. You can open up. Okay. Final exam. How does that work? For those of us who are going to be taking it. I'll be here. Final exam has 7 questions. And you get to choose 5. There are 5 questions where you get to choose. There will be 7 questions. You only have to do 5 of them. You can skip. You choose which 2 you want to skip. It's that simple. And also, just in case some of you are thinking about metagaming it, if you answer more than 5 questions, I just simply, unless you clearly mark, don't grade this or grade this one, I'm just going to grade the first 5 I see, because I don't want people to accidentally answer too many to try to up their chances, right? 7 questions, choose 5, they're worth 20 points apiece. So what are they on? There's always a question on file reading like you saw on the exam, like you saw on exam 2, and you saw on the practice exam. Something like that where I give you a CSV file, right? CSV file that you have to split it, after reading line by line, and do something with it. Last year was basically a file asking for you to find the animal with the biggest brain-to-body ratio in the file, okay? Not actually figure that out, but like here's a file with the format. Could you write a program that does that? Okay. Let's see. Then we also have a question on nested loops. So something along the lines of like given a list of numbers. So a list of numbers that in itself, each item is a list of numbers. So given a list, like this. Like, and this is an example question, right? Something like this, right? You get the idea here, right? How it's a list of numbers. Each item in the list is a list. Find the sum of all even numbers, or find the sum of all positive numbers, or something like that. Something where the math is fairly straightforward. Often it's a running sum. Okay, nested loop. Turtle program. I had a fun time with this one when I was doing it, when I had to do these online during COVID, where this one I'd actually give you a program and I'd ask you to figure out what my gibberish variables actually did. And so that actually required you to download and run it. Not really appropriate for this kind of format anymore, but here, this one is a draw the output, where I give you a program and you try to draw it, okay? Okay, it is not, the angles that you would need to know, that you would need to be able to draw for this one are, you've got your 90s, your 45s, and I do also do a 60-degree angle here. So just keep that in mind for this one. So nothing the shape is apparent once you draw it. It's just a matter of, getting there. So let's see. I'm trying to remember off the top of my head what I'm doing with these. Let's see. So there's always a Monte Carlo question. One semester it was, given the rules for 5th edition Dungeons and Dragons, calculate the amount of time, the chances that a level 1 fighter would kill a goblin in 1 hit. That was actually a lot of fun for me, not so fun for the students. And the answer is about 55% of the time, believe it or not. But other times I've given a literal game made for toddlers. The rules for a game made for toddlers, and you were supposed to simulate the that. Now that didn't mean that the program wasn't. It wasn't that the program wasn't hard to write. That game involved like having a dice with colors, and you'd had a wild card symbol on one of the dice where the player got to choose. So you had to simulate the player being efficient. And what it was is that this is literally a game that was designed to teach, but the rules are simple enough that it's designed to teach children, toddlers, the concept of taking turns. So it was a cooperative game. Okay. Next. So you'll notice that most of the stuff on the final we already know. Regex. We don't know. We're going to learn that today. Regular expressions. And they're always along the lines of this thing. Given file, remove sensitive info. So given like account names or something like this. Remove those account names. And account names are in the format of something, something, something. Now the fun thing about regular expressions is that you don't necessarily need to know regular expressions in order to solve them, because regular expressions are simply a simpler syntax to help you solve things. They're good at recognizing things like dates and times and patterns, okay? But knowing how to do this, if you know regular expressions, you can do this in 8 lines. 8 lines of code, only one of which will actually change for the exam. If you take the time, that is minimum, I think, 8 points guaranteed, just being able to read the file. I forget if it's 8 or 12 based on my rubric. So, all right, so this one is also on the exam is a loop question, and I label it, if you know, you know. Most of you will know who will know if you see it, if you've seen it. But this one is just a simple kind of loop question asking you to print out numbers. So the last one is a mystery question. It is something new in the sense that you will have not learned it in this class. You will have not learned it anywhere unless you actually went ahead and in like curriculum and stuff. Now that may be sounding unfair, but what I do is I give you the doc. It's basically I give you the documentation for something built into Python and tell you how to use it. It's not particularly complex. It's something useful, but it's something that is built into Python that we haven't gone over in this class. It's useful. Yes?
So will the final exam be on the computer or
on paper? Okay. So I give you the documentation. I say, here are the common commands. Like if I was giving you this is a list. Lists are used to collect a bunch of data into one variable. This is how you add something to a list. This is how you make an empty list. This is how you add something to a list. This is how you check if something is in a list, right? And this is how you iterate over a list. And I might then say, okay, write a loop that then adds up all the even numbers in a list or something like that. Basically, I give you everything you need to solve the problem in the documentation. The documentation takes up like half a page. And I'm very generous with the spacing to make sure it's nice and organized. It's not like dense or stuff. There's a lot of bullet points in there, right? So, but it is just simply, here's something new. Here's the documentation on how to use it. I'd say 90% of the students who attempt this one get I'd say at least 17 points on it. If you attempt it, there's a good chance of you getting it right because it is not hard. It is basically, it's not hard if you've been learning how to program because it's just simply saying, here's something new. Here's all the information you need to solve this problem. Here is a problem that is literally tailor-made for this thing built in. So I think that's I know that sounds weird to say, here's something completely new on an exam that you haven't had the chance to study for, but this is a test of, have you had the ability to learn things? And every student I've talked to who has taken this exam, who had tried that problem says, yeah, that's an extremely fair question, right? It's not that scary, and if new things scare you, then skip it, right? That's why I give you this one. This other loop question, it is just simply here's a for loop, write a loop that prints out numbers from 1 to 100 or something like that, but, and then the but asks you hey, maybe it might be something like skip every 7th number or something like that, or it might be printing out something instead of some numbers. So, it's basically print out numbers, but. Okay? So let's talk about regular expressions then, okay? And before we talk about regular expressions, we are going to have a bit of fun, because we need some fun after talking about this stressful thing. By the way, what are we going to do for exam 3? Mostly a lot of regular expression stuff and a lot of stuff that was on exam 2. So it's going to be a repeat of exam 2, essentially, but with regular expressions as well, add into there. So before we get into that, let's talk about something less stressful. So, and we need some context because we do have a lot of students who are not from the US here. So, would anybody like to explain the concept of Florida man to the class? Yes.
Florida, well, like, you know, like some people are crazy in Florida, like some things. Like I've watched like some YouTube channels on Florida man. It's like things that like only happen
In Florida, right.
For instance, feeding alligators, which is illegal.
Yeah, some things that only happen in Florida. There's this line from the show The Good Place. It's like, you're from Florida. By all accounts, I can't even let you into this bank. Kind of. Florida, a lot of states love to make fun of each other. It's just a fun thing where we sometimes poke fun at each other. There's this bit from Futurama about New Jersey where basically they're trying to find a place to live in New York, and they keep going from apartment to apartment that has some awful thing with it, and they go to a perfectly nice apartment, and they're like, okay, what's the catch? Well, technically we are in New Jersey, and immediately cuts to not one livable place. So the U.S. states love to poke fun at other states. This is all because we know that we're not Mississippi. Although Mississippi is doing pretty well, actually getting better in education, which is surprising to me. It used to be that they were like ranked 50th. They're doing much better these days and have been making a concerted effort in there. So good on you, Mississippi. Florida gets a lot of interesting stories out of it. You get the Florida man meme comes from basically Google your birthday and Florida man and see what comes up, essentially, and you'll get some really crazy stories. Okay? In fact, if you just Google Florida man in general, you're going to get crazy stories. I never know what's going to come up, probably something horrible. But it's always Florida man, Florida man, Florida man. Okay? And there's a reason for it. There is a reason for it. Florida man died on August 9th, 1925. A Florida man was arrested in Los Angeles, but not just because he was from Florida.
But did you see the video on YouTube?
There's a lot of it.
Florida man got arrested for feeding alligators and was sent to jail.
I probably saw that at some point. This is the way just headlines get written. There are certain rules in journalism how you write things, and that leads to certain words like fracas existing only in journalism. But Florida man has a reason for existing. Now, a lot of people say it's like, it's because the people are crazy in Florida. Florida is a very large state. It has an extremely diverse population. A lot of older people do migrate down there because the weather can be downright pleasant at the right time of year, although the hurricanes are making it harder to move. But it is downright pleasant. It has attracted a lot of people as a result. It is not like part of the South in the same way that like Georgia, Alabama, North Carolina, South Carolina. It's like its own environment, just like how the area around Baton Rouge is its own environment in the South. Okay, so Florida's its own kind of thing. It is a very interesting state. Plus, it has Disney and Universal. Can't be all that bad. So, but as they say from Miami Times, what it is actually one big reason for it is not just the large diverse population. It is also because that Florida has this culture with laws, with freedom of information laws, sunshine laws, as they call them. The idea here is that a lot of things is that it's extremely easy when compared to other states to get details of arrests for journalists in in Florida. So it's very easy to get these stories just simply by looking at the police databases and then write your articles. And then, in today's age when you need the advertising money for stuff to go viral, I mean, if one of these are crazy enough, that brings in plenty of advertising revenue. Okay? CNN also suggested a breadth of reports confluence factors such as public records, giving journalists fast and easy records to police report, the relative high population of the state, variable weather, and a lapse in mental health funding. There's a lot of issues with Florida as to why, or a lot of reasons and issues as to why Florida might have its own stuff going on. The other states that we make jokes about are Ohio. Ohio gets probably the best jokes, though, or the most prestigious of being made fun of, simply because so many of our astronauts have come from Ohio. And so that leads to the joke of, if so many of our astronauts are coming from Ohio, there must be something so wrong with that state that so many people just want to leave the Earth entirely to get away from Ohio. So, but seriously, a lot of astronauts from Ohio. So there's tons of stuff there, but what we're going to go back to is also, this was election season, so why not talk about elections? So the specific thing that I bring this up for is we're going to go back to to election almost a decade ago at this point, the 2016 election, but not necessarily the part of it that you're thinking of. Prior to Donald Trump entering the political arena, well, does anybody know who was the front runner in 2016 prior to Donald Trump entering? No, really eclipsed by that. Okay, and also before I do this, I'm not going to insult your intelligence and say I have my own and say I don't have political opinions and I'm a completely apolitical person. I have my opinions, and they're very strong, but they're also not necessarily appropriate to basically talk about in a classroom. You're here for me to teach about computer science. So when I'm picking on any candidate and it's from a particular party, it's because this is the most recent and memorable incident I can find, and not because I'm biased towards one party or another. When we get another another incident like this, I will be happy to take that as the new example for class. I want to be clear on that, okay? So it is a lot of fun, though. The front runner in 2016, before Donald Trump entered, was Jeb Bush. Jeb Bush, see? No, maybe some of you recognize him from memes. Because, of course, you might recognize him from memes. Right? Jeb wins meme generator. It is... So, anyway, Jeb Bush comes from a very large and powerful family, the Bushes. Well, large, I don't know. Powerful, yes. He was the 43rd governor of the United States, and let's see, why should we care about him? Because he's a member of the Bush family, which is this family, which includes former President George H.W. Bush and former President George W. Bush. He is George Bush's, he is H.W.'s son and George Bush's brother. Okay, so he was brother to the president. Now, he did run for president in the 2016, and before the entrance, he was assumed, because he was part of the political establishment, that he would basically be able to win the 2016 experiment. And by all accounts, his governance of Florida was fairly good. He was one of the first adopters of email and the internet into his presidency. And that's pretty important here in terms of our discussion. That's the reason we're bringing it up. He actually got the nickname the e-governor because he was willing to basically put himself out there via email to be contacted by constituents. This is a way of direct contact that was pretty new. And you might answer, well, why would you want to email the governor if for no other reason than to tell them how much you hate them, because that seems to be what happens with a lot of our representatives. There are reasons to actually contact your representatives other than to tell them you think they're doing a great job versus they're doing a terrible job, depending on how you feel about that. And one of the more interesting reasons is that you might be legally dead. This occasionally happens where paperwork gets messed up in such a way that you are accidentally declared dead. This prevents you from getting Social Security, from getting paid, from from getting all sorts of things done because you can't do any of that. You're dead. But I'm here. Well, obviously you're committing some kind of fraud because the system says you're dead. And the easiest ways to get those resolved is often to write a state or local representative or senator or the governor's office to try to get them to cut through this red tape to correct the issue. So there are so often like trying to correct these issues that can happen because of large bureaucracies. This may be the easiest way. And no, this isn't a matter of like needing to also bribe anybody to grease the wheels here. The U.S. doesn't really operate in that kind of way. So we'll see some emails, by the way, of what kind of emails the governor might get sent. Okay, because he did have a lot of emails, and he got quite the collection of them. So in the up to the 2016 election, he decided to release all of his emails. Now again, the state of Florida has these powerful sunshine laws, but certain data in these is protected. Things like social security numbers, personal identifiable information, things that you would think are sensitive data, they're probably protected, right? Okay. However, when Jeb Bush released these emails, he did not redact them. Jeb Bush email. So email release. Let's go ahead and look. I think, and specifically an article from The Verge, February 2015. So this is from February 10th, 2015. Jeb Bush dumps emails, including social security numbers of residents online. Subtitle: Florida man strikes again. Rumored 20, and this was before he was actually running for president. Okay, now there's a reason I'm talking about this, by the way. Okay, I'm not just doing politics and political and election-related stuff just for giggles. Okay, so he says, on the spirit of transparency, I'm posting the emails of my government because again, Florida had this huge culture of transparency. So here's a couple of these that have been redacted afterwards. Right? Like some of this are just emails, like these are very personal ones over here. But here's one that is kind of stuff. Like here, Dear Georgian Governor Jeb Bush, RE blank, which is probably a name, social security number blank. This letter is to inform you of the facts regarding blank's employment with the House of Hope Orlando. Blank is a valuable part of our boys program. So this is basically just basically a letter of basically saying, no, this person is legit. Please help, with his issues with probation, because he's been great. Another one is here, please, we need help for this child and we're having trouble with insurance. Here's like all the insurance information and stuff like that. Things like this. So very desperate emails and stuff like that. We have very broad, they have very broad kind of thing, laws in Florida with regarding this information, but not that broad, right? Not this, you shouldn't really be able to get these things released, especially social security numbers. Again, those of you who are not from the U.S. should understand that the United States does not have a national ID. It is actually quite the contentious issue for various reasons, for a lot of different reasons, to create a national ID, a specific number for a person like every other country has. We have state ID, we have state driver's license and state IDs, but we don't have a national ID system. De jure. We don't have one by law. But we have a de facto one, and that's the Social Security number. In fact, the Social Security number, at least the ones I got, said this is not intended to be used as an ID number, don't give it to other people. But because of various tax things and other stuff, it became a de facto ID. So it is basically, you're right, it is basically a very insecure piece of identifiable information. Okay, so the thing, and here they have been basically saying they've been stripped out. So the main thing is that occasionally as a programmer, you may be called, or even just as a person, you may be called on to basically say, we need to release this stuff to the public. Please, please go through and remove all, identifiable data from it. That can be a pretty damn tedious task, right? Going through and basically saying how to, to remove stuff. Now, if it was a matter of you basically saying, we need to remove the word like taco from our document, right? That's actually fairly easy to do, right? All you would have to do is you'd open up in Word or something and you'd say Control F, right? And you can look for taco, and then there's a find all. In a lot of places, there's a find all, and then there's a replace kind of function, like here, edit. There's a search, find, and then there's a replace. It's often Control H in a lot of documents where you can find all instances of one word and replace it with another. And kind of, wouldn't it be easier if I could just simply, for Social Security numbers, that's going to be our example, for Social Security numbers, if I could do something like a search function. If I could just simply press Control F and say, I want to find all Social Security numbers. Social Security numbers look like this. And here's the fun part. You can do that with the find function if you know how. Because it might be a bit hard for Reed and the people in the back, but look what that says. Checkbox that says use regular expressions right there. It's built into a lot of stuff. It is built in, it is its own special sublanguage that is built into a lot of things. If you go to, if you use VS Code, there's actually a little symbol in the search function that, and it's really subtle, and you'll have to click it, but it looks like this, and that is kind of the symbol for regular expressions, a dot and a star, which are two very special symbols in regular expressions. But that's kind of come to be the symbol for regular expressions. They're extremely powerful things. Now, the limitation for regular expressions is they can do a lot of things, but what they cannot do is something called parentheses matching. Basically, anything where you're trying to count a certain amount of, or do a counting balance kind of thing. Say, I need as many open parens as I need closed parens. That's kind of a limitation. But you can do a lot with that. Regular expressions are, in fact, no more powerful than flowcharts. Very powerful if-else statements, but you can do a lot with flowcharts. Okay, very powerful flowcharts. Okay, so let's talk about that. A Social Security number looks like this. For those of you who don't know, Social Security number looks something like this. 123-45-6789. It's 3 numbers followed by a dash, followed by 2 numbers, followed by a dash, followed by 4 numbers. Okay? And that's what a Social Security number is. If this is yours, I'm so sorry, but it's a rough day to be you. So Social Security number, right, so how does this work, regular expressions? Well, regular expressions use special symbols. In fact, I'm going to open up a special website I use for regular expressions called Regexer. And here it is spelled out. Regex. That's short for Regex, which is short for that's Regex, which is short for regular expressions. You might also hear them called Regex or Regex. Or Regex, I don't know, I call them Regex. And then R, because websites are weird, okay? And then Regexer, learn, build, test regular expressions. Okay, so we'll see this thing up here. This is where we'll build a regular expression. I'll just go ahead and delete that. It's going to be in between our 2 dashes. I'll show you how, basically today is learning about the syntax. Tomorrow is going to be learning about how to apply this syntax in Python. Because the syntax, once you learn for this language, it is applicable to all programming languages. All programming languages have a regular expression library built into it. And we have a bunch of text in here to test, that we can test on. So first thing that you can do with regular expression is you can use it like a just Control F thing. If I want to find the word, taco in here, no match for taco because he's boring and didn't want to talk about tacos. But if I say, I like to eat tacos, not eat tacos. Tacos are the greatest food ever made. Yummy tacos. Right? Then there we go. It's found 2 matches for tacos. Why didn't it find this one? Because regular expressions, like a lot of things in computer science, are case sensitive, meaning they care about capitalization. Okay, we can change that by, but generally speaking, we don't really care about that too much. So you can use it like a find replace. If I just simply say E, it's going to find all the E's. If I find all the THEs, it's going to find all the THEs that are either by themselves or part of a word, right? Okay. So you can use it like a find replace. Now, what about, let's see. So the main power of regular expressions is being able to kind of define wildcards and groups of things at once. That's one of the main things. So say I wanted to look for a number, right? I could look, looking for a specific number is annoying, but I can also use I can use a special command to say I want to look for any number, any single letter that represents a number, any single digit, /d. Slash here is like in our text editors and in Python. Slash is a special command. /d looks for a number. I don't know if he's the one and only, but it gave me an excuse to use a 1, and it found it. Here, for instance, I'll put in my email down here, just as a random bit of text, tug85861@temple.edu. Right, and we see, we have 5 matches here, and then the 1 extra over here. So it found all instances where that matched up. Made sense? So that finds a single digit, /d for digit. Fun fact, any of these things, we're about to learn 3 of these things, okay? 3 of these slash commands. Technically, I'm going to cheat and teach you 6 of them because any of these can be inverted very easily. So anything that's a digit, but if I capitalize it and turn it into /d, it looks for anything that is not a digit. Notice how it highlights every single character here that is not a number, right? Everything, including the spaces, is not a number. TUGs match, but not this one, right? So this actually already answered, just with this, we've already answered our question on how can we find a social security number along the lines of what we had, right? So here I'm going to go ahead and write our social security number. I'll write a social security number, 123-45-6789, right? And let's go ahead and write this, okay? /d for 3 numbers, right? So notice how it's finding any 3-digit number right here, right? I found a 3-digit number. And then, so what we write here is the pattern. What we call this a pattern, what it looks for. So we're writing anything that matches the pattern of a social security number. /d for 3 digits, followed by a dash, because we want a dash, because social security numbers have a dash. Then followed by 2 digits, /d, and dash, and then, ta-da, that's it. And that will find any number of social security numbers that are in this, in whatever your input is. I'm sure that somebody's over here, but, right? And if it doesn't match it, if it doesn't match the whole thing, like here, it's not going to match the whole thing. So it's looking specifically for this pattern, and you'll be able to return them very easily. And you'll be able to see Python has some built-in commands that automatically will grab all these things for you. It's great. So that's that. So /d is pretty great. And we can see, hey, if I do Control F here, /d dash /d /d / if I put this in here, mark, find, what did I mess up? Oh, he got hit use regular expression. find, boom, found it, right? See, so again, this is the same language that's used in every single programming language for regular expressions. It's a very powerful tool. It's built, and there's a library built in for every programming language. Okay, so besides the /Ds, we also have another useful one, /W, for word characters. Matches any word character, it says over here. This is part of the reason why I like Regex, or it tells me what I'm looking at. It does include digits, as you notice. It matches any word character, alphanumeric and underscore. Basically, any character that would be legal in ASCII-only variable names. Basically, if it could work as a variable name or as part of a variable name, /W will match it. Okay. So that's kind of good for kind of like almost any wildcard. And then finally, you've got /S, which is useful for when we're splitting stuff. /S says I'd like to find spaces, right? Any kind of, so if it's a tab space, so if it's like a tab kind of operation, it will match that too. So it matches your tabs and your spaces. Anything that's basically used to separate for white space. Okay, and again, we can invert each of these by capitalizing. Capitalizing gets you the opposite. These are things that will get mentioned at the beginning of on that back of the front page of the first exam, by the way. I'm sorry, of the third exam. So those are very powerful. Now, those are the three kind of classes that are built in, but you can make your own. You can make your own character classes, so to speak. So notice that /W, right? It highlights alphanumeric and underscores. What if I only want letters, right? Or let's actually make this easier. What if I only wanted vowels? A-E-I-O-U, right? What if I only wanted to look for vowels? So we can use brackets to create a character class. This is a particularly useful one. It's particularly useful if you forget what those / commands are. But basically, a bracket say one of the things in this bracket. So if I say I want to find all vowels, A-E-I-O-U, this will find all vowels. Sorry, this will find any single vowel. See? Any single lowercase vowel, right? Any one of. If I wanted to say, hey, any vowel followed by the letter, let's say, N, then this is any single vowel followed by an N. See how that works? Is everybody following so far, right? It's just a very simple language. It does, again, least surprising things. So expression, right? Now we could do that with, if I wanted two vowels in a row, all I got to do is copy this, paste, and paste again. Actually, there's an easier way to do that, but I'm not going to get there yet. I'm still going to focus on this, right? Got a specific thing. Character classes, making your own character classes, and repetition. Yes?
Are the brackets specific to like vowels, or if I put like word in there, it would look for W-O-R-D?
That would, great question. If you did it like this,
Yeah.
This would find any vowel followed by any vowel followed by a W, or any vowel followed by an O, any vowel followed by an R, and any vowel followed by a D. So created, IO, OR, supported, validate, right? You see that how that's working right there. It's any one of these followed by any one of these. Okay? All right, so let's talk about any letter. What if I wanted to find any letter? A, D, it's like A, right? A, B, C, D, E, F, G, H. This is going to take a while. Is there a shorter way to do this? I ask, knowing, of course, there is a shorter way to do this. You can, when you do the dash like this, specifically inside a character class, it gets smart. and figures out you want A through Z, which is nice. In fact, you can do capital A through lowercase z to get all letters. And if you read Y, it says anything from character code 65 to 122. Right? Remember how I said uppercase A is 97? Sorry, lowercase a is 97. Uppercase A is 65. So it's saying basically anything from this range to this range, numerically speaking. So that can be useful. Finally, let's go back to vowels. A, E, I, O, U. So lots of vowels. A lot of things here. It doesn't matter what order you're doing since it is one of, by the way. So I could do it in any order of those. But let's say you're trying to find everything that is not a vowel, okay, for some reason. Right? Again, we're dealing with the fact that there's a lot of characters to specify. A lot. So again, create a character class, and then this is the last special thing, right? The dash was the first special thing. The other special thing to do with character classes is that if you put the caret symbol, that little triangular symbol, which on a computer is Shift-6 on the US keyboard, right? That caret symbol, which we often use for exponents, that inverts the character class. Basically says anything that's not one of these. So see how it's highlighting everything but a lowercase vowel. These are very useful commands here. Okay? Very, very, very useful commands. Okay. Before I go on, let's just go ahead and ask the question, or answer the question that some of you are asking in your head. So what kind of questions do these look like on the final exam? Given a file, so one thing I've asked on the final exam is something that looks like this. Given a file, remove all temple emails from that file. Where a temple email is defined as 3 letters. Here, let me remove this. It's defined as 3 letters followed by 5 numbers, the @ symbol, and temple.edu. This part's actually pretty easy to do because all you have to do is write temple.edu, right? Kind of. I'll get into that in a second. That part's very simple. And then for here, we kind of already know how to do this part. It's A to Z. The first 3 letters are A to Z. And then you could, without knowing what we're about to learn, you could do A to Z, A to Z, A to Z, right? Wait, did I do that to me? Nope, that's 5 of them, right? And then the @ symbol, right? And that matches this thing. Although TU emails are always like TU and then a letter, right? So it would actually be TU and then any letter followed by any 5 digits, right? I specify what a temple email is on that problem. I say it's a T, it's followed T, then a U there. So something like that. Given a file that contains these, redact it. And the ability to actually replace everything that matches a pattern in a file, in a string, is a single command. It's pretty nifty. Single command. So knowing the regular expressions is pretty nifty. And like I said, this is like 8 lines of code, 3 of which are needed to open the file, 3 of which are needed to print something to a file. And writing something to a file is super simple if you haven't seen that yet. So that's the kind of question you'll see on the final exam. That is one of the kind of questions you'll see on exam 3. The other kind of questions you'll see on exam 3 for this is something like, given this pattern, right, over here, select all of this, I'm going to have a bunch of strings over here, right, with a bubble in symbol. Bubble in all the strings that would match this pattern. Make sense? And then I'll do the reverse as well, where basically, given a string, bubble in all the patterns that would match this. And the way I typically grade those is that every bubble is a hit or miss. So basically, if you bubbled it or left it unbubbled correctly, then you get credit for it. So you don't just get credit for the active choices. You get credit for the ones you didn't bubble as well. So it's the fairest way to do things. It also makes it the quickest for us to grade. So those are the kind of questions that for regular expressions. And you see now that they're not too complex, so let's work on the last part of it. A last note though, I mentioned about the temple.edu addresses, right? I mentioned that there was one part of that was tricky, and that specifically is the dot. Remember that where I said dot star is its own special, is the symbol for regular expressions? In fact, it stops doing something and just gave me warning when I put in dot star. I'll get into what star is in a bit. Dot is the wildcard character. It says match anything. That's what dot is. If you want an actual period, you have to escape it. That is like the one pitfall that will knock you a single point on some of the questions, on the coding question. On the questions where we actually look at like bubbling stuff, that can affect you, but just know that for a period, we want that you need slash dot. Okay? That's like the one special character that I'm going to care about. Okay? Now, let's go back to our vowels. A, E, I, O, U, right? Now, it's annoying to do something like this, to have to say, hey, I would like to get 2 vowels in a row. I'd have to copy paste this, right? We learned that programmers really do not like repetition, okay? So, or having to manually do repetition. So we have a few different ways of doing repetition in regular expressions. The first is we've used brackets, so now we're going to show what curly braces do here. Curly braces are what we use for repetition, and it's very straightforward. Boom. That says 2 of the preceding thing. Okay, let's do a bit of a simpler example. A. There we go. Right, that matched 2 A. This expression says match 2 A's in a row. It's called a quantifier. Match 2 of the preceding thing. So if it says H, A, then it's looking for an H followed by 2 A's, not an H, not ha-ha. It's looking for ha, not ha-ha. Make sense? It's 2 of the preceding character. Any guesses how I would make it match ha-ha? Any guesses on how I would group an H and A together? Close. Parentheses, yes. You can do that. You can parenthesize anything, right? Do these things together. It's not really going to be something you need to know for the test, but it's good for knowing this is how that works, okay? No, you don't need to know that for the final. I'll probably have it on the exam where basically you group stuff together like that. Right, so 2 of the preceding character. So let's look at this. So we've got ha, we've got ha, we've got ha. Let's just keep going with this. We've already committed to this bit, so. And ha. Okay. So if I change this to 3 now, 4, right, it will match subsections. Let's delete that bit and just go 2. And just want to talk about something here. So it matches, so H and then 2 A's, then it matches, we've got a match here, H and 2 A's, then we've got H and 2 A's followed by 2 H and 2 A's, we've got 2 more A's, right? So we're just looking for 2 A's in a row. So some of the more keen-eyed among you who love to say actually might be going, wait a second. We've got an H and A over here, but why isn't it matching this H and A? And the answer is that the default way for regular expressions to operate is to be greedy. Basically, they will go forward and they will match as much as they can, and then they'll continue from where they left off. Okay? They will continue from where they left off. Sheesh, this headache's getting worse. Yeah. All right. Well, so that's why you've got the match. Why we've got it matching the way it does. Okay. I can also put a comma there, and just like in Python, if you don't leave it, if you leave it open, it says 2 to any number, but usually you want to put a number here. And this should be fairly apparent as to what that does. We've got A, 2 to 4, right? Makes sense? Matches between 2 and 4. So, right? This can be used, so that could be useful, 2 to 4. So that's your quantifier. Basically, you can match, you can use it 2 ways. Exactly, a range, or at minimum. Okay? However, I'm going to tell you that these are actually fairly uncommon in regular expressions in general. The 2 things we typically use in regular expressions for quantity are, well, one's pretty interesting and one's a bastard. So let's go ahead and see them. So first, let's just grab our H and A again. And I'm just, again, so we'll go with H, we'll go with ha, 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 and all these other ones, okay? So here is our first one, the plus symbol. Plus is short for, plus doesn't actually need to exist, it's this. Plus is short for at least one of. But it is such a common operation, but it's such a common statement in these things to say, I want to find at least one of any number of these, but I just want at least one of. That we put it right there. Okay? It's got its own special thing. Okay? But the really special one, that little bastard of one, is called the clean star. And that's what the star symbol is. And this is why we call, and why we have dot star being the symbol for regular expression. Star is short for, and this is going to be a very weird sounding expression, at least 0 of. At least 0. Meaning you can match any number of these things, including 0. So let's go with, I'm going to go ahead and just simply kind of show it off here. We have H followed by any number of A's followed by another H. So, right, so here we have, if we had a plus here, that would be an H followed by at least one A. Okay? So this doesn't get highlighted. The rest of them do because there's any number of A's between your H's. But if you really, but sometimes when we say any number, we mean any actual number, and sometimes when we say any number, we mean any number, including 0. That's a number. So that's where that star comes in. Okay? Now, I highly recommend you take the time if you want to look at these and play around with these on your own. I'm not dismissing you yet, by the way. I'm going to just simply tell you where we want to go for this. Okay? If you want to read more about regular expressions, automatetheboringstuff.com. Chapter 9 goes over text pattern matching with regular expressions, and he starts out, oh, this is how you, if you want to check if something is, write a function to check if something's a phone number, right? Check if some text is a phone number. Here's how we would have to do it with just what we've learned so far in Python, okay? Versus if we knew how to do regular expressions, we could just do it like this. Now he does it with a slightly different syntax than I'll use it. He does it with the more preferred and definitely more efficient syntax, computationally efficient. I like my syntax to be just nice and very simple and easy to do, and requiring basically one line of code. But it is very straightforward to learn these kind of this syntax. There are a few other symbols. Now, I think there's just really one other symbol that we need to. No, 2 other symbols, right? Okay, 2 other symbols, and then I'll talk briefly about where the heck these come from and why we're learning them here as opposed to a later class. Because most of you will never take that later class, even if you're a computer science major. Okay, other symbols. Let's go back to our ha example. Okay. So a couple other symbols. One is our question mark. Question mark is very straightforward. It's another one of those kind of range things. Question mark is just short for a range of 0 to 1. It's just, that's an often enough thing that it has its own symbol. So notice that a lot of basically every one of those special symbols that I just showed you can just be written down as a range. So this one says 0 or 1. In other words, the A is optional, right? You can think of that. This is useful if you're trying to match something that's got a British spelling, like right, color. If you're using Commonwealth spelling, right? There's a lot of, just because Americans and the British share a very similar, the same language doesn't mean we use it in the same way, right? So here we're saying the U is optional, right? The U doesn't necessarily have to be in there, okay? Another way we do this, if you blank on ranges and stuff, is that we can use this bar, which in other programming languages, rather than writing out rather than writing out or, you use bar use two vertical bars for an or symbol. That's shift and then the slash key. So shift and the key right above the enter key. So color or color. Basically, what that does is basically says I want one side or the other side, right? It basically allows you to do optional, so it lets you get very complex with these things, okay? And that's it. That's everything I need to teach you on these. So where in the world do these come from? Regular expressions. Regular expressions come from regular languages, as we call them, right? You can read the Wikipedia article on this, sometimes called Regex or Regex. When mathematician Stephen Cole Kleene, that's what we named this Kleene star, formalized the concept of regular language. So these are extremely powerful tools, but what they are is that these are essentially, let's see, these are basically utilizing a mathematical thing called a regular language. Let's see. Regular language or rational language is a formal language, and these are basically strictly mathematically defined languages, and they use complex grammar, like saying, hey, we've got a symbol for an empty language that doesn't have any data in it. We say that any symbol belongs to this language, right? So we basically got these kind of symbols for these things that's saying that hey, we can union them. There's all these formal definitions for an alphabet saying, hey, a collection of regular languages over an alphabet is basically saying there's a bunch of symbols. What's interesting is that these are, a regular language satisfies the following equivalent property. It is accepted by a deterministic finite automata, which is basically says this is a deterministic finite automata that accepts only binary numbers that are multiples of 3. They allow us to kind of basically say, hey, we've got a flow chart to basically say, we've got this mathematical flow chart to say whether this is a valid state or not. This is some kind of valid sequence of states. These things don't have any memory. They just simply say, if I'm in this state 2, I could go either to state 1, or I could see a 1 and go and stay in state 2. If I see a 0, I'm going to go to state 1. If I see a state 1, I can either finish. If I'm in state 1, I can either finish, or I can see a 1 and stay in state 1, or 0. So seeing a 0 basically says switch states, switch what state I'm in, and then seeing a 1 basically says I'm going to stay put. Now, and then basically the state being over here says we need to have an even number of zeros in order for this to be accepted. So, no, you don't need to know this for the exam, but what this is that these are the building blocks for things that we do in a class called automata theory. And these build up kind of from the concept of what if we have very basic memory added, that we can only remember the last thing we did. And we can remember the thing before that, but only if we've previously processed the last thing we did. It's a kind of special memory called a stack. And then if you add a second stack, that's actually all you ever need in terms of memory to get infinite memory. And at that point, you've created what's called a Turing machine. So these things can be, and basically you notice that these are mathematically defined, so Turing machine. Right, these things are mathematically defined, the Turing machine is mathematically defined, and if you have these ideas right over here, finite state machine, push down automata, that's one stack, and then a Turing machine, basically you can mathematically prove what you can do with each of these, right? What is possible for a computer versus what is impossible for a computer. Each of these machines has, in turn, its own language equivalent, as opposed to a flowchart. Right? For finite state machines, those are regular languages, which is basically very strongly correlated with our regular expressions here. For push-down automata, those are context-free grammars, and for Turing machines, those are Turing-complete languages. Pretty much any programming language I can think of off the top of my head is Turing-complete, meaning that theoretically you can do in one programming language what you could do in any other programming language. Even languages that are weird, like Ook, one of my personal favorite. Do we have Ook here? Yes, we do. Yes, it's part of the BF language. So Ook is a language that is designed like, really doesn't have its own separate issue for Ook. Ook is a language with 8 commands, all of them being combinations of Ook and Ook. Specifically, the commands look like this. And there's 8 variations of these, and that's actually enough to be a fully programmed, a Turing-complete language. You can do quite a bit with that. All right, with that, I am signing off for the day. I'm going to find myself a Tylenol or something. All right, take care. If you need to speak to me, I'll be right here.